Welcome to the lecture 24 of the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. In this lecture, we will continue our discussion of the graphical user interfaces and we will discuss basic event handling. Although we have seen how do we handle different events in graphical user interface programming, but we will look at the underlying code behind those events and how those events are handled. And by the events, we mean that when we click on a button or when we press a key on the keyboard, what should be the response of the user interface. We'll have an introduction to event handling. We will look at event handling using the inner classes, and we will look at the event handling using the anonymous classes. And the relevant reading material can be found in the detail and detail book, chapter 12. So we understand that graphical user interfaces or GUIs are event driven. The interface waits for us, it waits for a response from the user, it waits for a click from the user, or it waits for a pressing of an enter key, it waits for a pressing of a button, and then it will respond according to what we have coded behind that object that is on the screen. When the user interacts with the GUI component, the interaction known as an event drives the program to perform a task. The code that performs a task in response to an event is called an event handler, and the process of responding to events is known as event handling. So whenever we add an object to our form, for example, a GUI form, then we will be, for example, we'll be adding objects to those forms like buttons or labels or text fields, and those objects will be performing some function. For example, if we click on a button, there must be some event handler for that button that should do what we want the button to do, and that process is called event handling, and the code that performs that task is called event handler. On-screen components cause events to occur when they are clicked or interacted with. Program's execution is indeterminate, that means the program waits for us until we close it, or it responds to us wherever we want to interact with the program on the screen, or whichever objects that we want to click or interact with. Event source, a GUI component that generates or fires an event. This can be a button, this can be a text field, this can be a label. Event is the user interaction. For example, the process of clicking on the button is an event, or the process of pressing an enter key or any other key from the keyboard is an event. Now we understand that our interface should respond to these kinds of events. Event listener is an object that has implemented event handlers to react to an event. So an event listener for a button would be, for example, when we click on the button, then it should have a click event listener, a mouse, for example, a mouse listener object that should handle what we want the button to do. We should note that the delegation event model or event listeners must be registered with an event source in order to receive notification. Now we'll look at an example of how we register an event with the source, but naturally we should associate an event listener with the source. For example, the button over here is the source. We should associate the action a listener to that button in order for that action to be performed by that button. If we do not, and this process is called registering the event listeners with the event source. So the button is our event source, that is where the action should occur or the interaction should occur, and the action listener is where what should that button do then. And until we have registered this action listener with this button, it will not do our desired operation. Listener's appropriate method will be called when event occurs. When the button is clicked, an appropriate method will be called. For example, when we developed a graphical user interface for a calculator, the appropriate action for a plus button was when we click on the plus button, what should happen is the content on the display should disappear. It should, and the number should be stored in a local variable, and it should allow us to enter another number. Similarly, we associated different functions or different functionalities with the buttons, and each of those buttons, for example, if we click on the 1, it should display a 1 on the screen, and so on and so forth. And that was the process of event handling. We were handling the event for each of those buttons. How event handling works: each event type has one or more corresponding event listener interfaces. Action events are handled by action listeners. Mouse events are handled by mouse listeners and mouse motion listeners. When the user, for example, presses enter in a text field, that will generate an action event. An action event occurs. It has its own methods to handle those kinds of events. It is processed by an object that implements the interface action listener, and we will see this in the examples. To handle action events, a class must implement interface action listener and declare method action performed. And you must remember this from our implementation of the calculator example, that each of the button had this action performed method, and that method was coming from the action listener interface, that was being overridden from the action listener interface, and we were adding a functionality to the action performed method, and that is what the button to which the action performed method is associated. And whatever the functionality we added to the action perform method, that button was supposed to perform that action. This method specifies the task to perform when an action event occurs. So this is a hierarchy of the different events that can occur. So we might be interested in this one. For example, an action event, we have handled this kind of events in our previous examples. So if it occurs when the user clicks on a button or the user presses the enter inside a text field. So the action event occurs when we click on a button. For example, when we clicked on 1, we had associated an action perform method with that button, and the functionality of that method was to display a 1 on our text display area. And similarly, we had action performed methods with each of our buttons. Mouse event can also occur when the user presses, releases, or moves the mouse. The mouse has different events. For example, when I'm moving this mouse, as we can see, this pointer, some of the graphical user interfaces might respond to this movement as well. For example, if you hover it over a button, the button's graphics might change, or the look of the button might change. So we can have handlers for these kinds of events. One can be clicking on the screen, one can be moving the mouse on the screen, or certain objects. For example, if you want to add some color to this graphic, and what you can do is, if I move my mouse over this logo should maybe enlighten or something. So that will be a kind of an action event handler that you would define for this hovering of the mouse event. And then there are key events. The user presses, releases a key on the keyboard, and this can all be imported from the java.awt.event. When we need these events, we can import all of these using the static. Event handling with inner classes. Before an application can respond to an event for a particular GUI component, you must perform several coding steps. And these steps are: we need to create a class that represents the event handler, and that can be an inner class that we discussed in our previous lecture. We create an inner class that implements the action listener interface, and this, as we can see, is an inner class. This is a private class. This will be defined inside the class where the event is occurring. Implement an appropriate interface known as an event listener interface in the class, and it has this action performed method that we have used previously, and we include functionality inside this action performed method that is then listened to by the object and performed accordingly. We create an instance of that class, for example an event listener. We create this object of this inner class. We call this event listener, and then we register the listener with the GUI component or components. This process is known as registering the event handler, or in simple terms we can call it associating this object that we have created with the particular component on our form. So this process is called registering the event handler with the particular component. If we forget to associate or register a particular GUI component's event type, for example, if we forget to do this for text field 1, we will not be getting any response from text field 1 even if we try to kill it or press the enter key. Events of that type will be ignored. So this is the process of registering an event listener with a GUI component. For example, if you have a button, what we can do is, for example, if we want that button to do something, then we will need to create an object of this inner class, for example this one, and then we associate that object with that button, and in this case we are associating this object with the text field on our form. And we must register for each text field that is there on our form. If we have buttons or any other components that we want to associate with a certain event, then we will have to register the event handler for that event to that component. For example, we can have buttons, JButton and JLabel classes. A JButton class, the most common component of button, is a clickable on-screen region that the user interacts with to perform a single command. JLabel, on the other hand, is a text label, is simply a string of text displayed on screen in a graphical program. Labels often give information or describe other components. For example, we sometimes add a label to a text field that describes the function or the reason for that text field. There are methods associated with these components. We have used some of these methods. For example, we have a public JButton, that is the constructor of the JButton class. Whatever text that we add to this constructor or pass to this constructor, that will be displayed on top of the button. Or we can have public JLabel, and if we pass any text to the between these two parentheses, that text will be displayed on top of that label on our form. It creates a new button, for example in this case, or a new label for in this case, with the given string as its text. Public string get text. If you remember from our calculator example, we have used this method. We use it to get a text from a button or a label or a text field. All of these components have their own get text methods, and we can use this method to get the text from that component. So it returns the text showing on the button or the label. Public void set text, we have used this method as well. So whatever the text that we pass between these two parentheses to this method, that text will be displayed or set on top of that component, in this case the button or the label. Similarly, we have the components JText field. A JText field class, a text field is like a label, except that the text in it can be edited and modified by the user. A text field accepts text from the user, so we can add text to it, we can type text into a text field. The label on the other hand is static, we cannot type text to it. We can associate events with that label, or we can attach it to other buttons, so that we can change the text in a label in response to a button click. But the text field on the other hand allows us to add or enter text into the text field. Text fields are commonly used for user input, where the user types information in the field and the program reads it. For example, this is an example of a text field where we can add text into the text field from our keyboard. Text area or JText area class on the other hand, a text area is a multi-line text field. As we can see in this case, if you want multiple lines in our text field, then we can use the JText area that will add multiple lines. For example, for long text we can use the JText area. There are methods associated with these components as well. For example, the constructor of the JText field will accept an integer value that shows the number of columns that can be fit into this text field, or simply it can be the size of this text field if you want, and the column shows the one letter. For example, this can be, we can say that if you count these letters, then this might be the size of this JText field. So you can initialize a JText field with some initial size. The JText area, on the other hand, you can pass on the number of lines that you want to set by default to the JText area and the size of this JText area, or the number of letters that you want to you want this JText area to have by default. So this just tells us about the size of the JText area. It creates a new text field that is the given number of columns or letters void. So we can set the number of letters that we can have in that JText field by default in the constructor of the JText field. Again, it has a get text method, and we have used this get text method for our text field in our calculator example. It returns the text currently in the field. So for example, if you want to read this text from this text field, you can use the get text method on this text field and you will get this text. Similarly, we can set the text, and we have used this method as well in our previous example. For example, you want to change the text, you can set this text to any text that you send between these two parentheses. You can solve this example. For example, whenever the user presses enter in either of the first two JText fields, the third JText field displays a string combining the shorter of the two words from the first JText fields followed by the longer. So you need to add this some code that, for example, if you click anywhere and you have these words in these two JText fields, you click anywhere in this text field, what should happen is it should combine these two words or concatenate these two strings and display it in this third J text field. Now it is doing some additional comparison between these two strings, and this will be clearer when we study strings. But what you can do currently is just to concatenate. First, read the text from the text fields. For example, for the text field 1 it is given. You can read the text from the second text field. You can add these two or concatenate these two and store it in the result variable, and then you can store it or display it in the text field or this third text field over here. And this is another example that you can solve. The user enters integers into the first two text fields, presses the plus button, and the result is displayed in the third J text field. If you have solved the calculator example, this one should be easier for you. All what should happen is you have this first number, then you have this second number, then you have three text fields, and you have this one button. When you click this button, the result of this should be displayed in the third text field.